This is a telescope we have currently orbiting in space called the WISE, which stands for Wide Field Infrared Survey Explorer. It is a telescope that is used to see stars that could not form, such as a brown dwarf, and can be detected with infrared light waves.
Astronomers are interested not only in the bright stars in our neighborhood, which are easily seen here around the sun, but also the small dim objects we can't readily see. Finding these is one of the prime objectives of NASA's Wide Field Infrared Survey Explorer, or WISE. As we move further away from the sun, we focus only on our neighbors within 26 light years. Within that volume, we increase the brightness of the faintest, reddest stars to make them more easily visible. These objects, known as M dwarfs, are the most common type of star in the solar neighborhood. Now, viewing from a distance of 30 light years, we circle all of the known brown dwarfs, faint objects with too little mass to shine stably as stars do. The blue circles show all of the previously known brown dwarfs, while the red circles show the ones that WISE has identified for the very first time. This updated census of our solar neighborhood now shows that brown dwarfs are much rarer than stars, there being roughly 6 stars for every known brown dwarf.
Can you find the brown dwarf star amongst all these stars? No, I can't either. So how do astronomers know what they know? We use WISE to look at specific spectra of stars. You can see regular stars, the spectra blue, green, and red on this graph. But the brown dwarf stars, you can see their spectra are different. They have more green. So we're going to use some WISE data, and we're going to look for the greatest number for the ranges and determine which of the stars in that particular area are the brown dwarf star. Take a look at this data that we received from WISE. These are the infrared rays that we talked about and the different wavelengths. We're going to actually complete the calculations in the table, and the highest numbers that we receive will indicate where our brown dwarf is. We suspect it's in one of these stars, but again, we're looking for the star that is going to have the largest wavelength. And that is going to give us that green color, and it's going to indicate that it's our brown dwarf. All right, to show you how I did this, I filled out the first half of the table for you, and all you're going to do is divide W2 by W1 and take those wavelength values, plug them into your calculator, and then record them up to 3 decimal places. And there you can see that's how we got the first value. Then the second value, we divided W3 by W2, and we received this decimal value. Again, we're going to do that for the rest of stars 2 through 6. And the columns, the 2 columns with the highest values, that is going to give us an indicator which one of the stars is the brown dwarf. And it's going to give us the indicator of which has the longest green wavelength. And again, it will tell us exactly where to find the brown dwarf in that star system. I look forward to you completing the data table and finding out where our brown dwarf is.